In a wide variety of disciplines, scientists, engineers, and analysts are faced with the task of summarizing and interpreting data involving many variables. Such multidimensional data come as experimental measurements, simulation results, or survey responses. They describe such diverse phenomena as network traffic, software performance, customer choices, or the effectiveness of medical treatments. Dynamic, interactive, graphical methods are very helpful in the analysis of such complex data. Using these methods, the user can quickly become familiar with a new set of data, discover relationships among two or more variables, and locate and identify unusual points. Often, features will quickly become apparent when it would have taken a very long time to discover them using analytical and static graphic methods. Some would escape detection altogether. Xobi brings contemporary dynamic graphics for data analysis to the workstation environment using the X window system. This is an Xobi window. At the center is always a scatter plot representing some two-dimensional projection of the data. This could be a two-variable plot, or more variables could be represented. Across the top is the main panel, a row of buttons representing major Xobi modes and commands. To the left is a secondary control panel, which corresponds to the mode selected in the main panel. To the right is the variable selection panel. It has two main functions. The first is that it displays information about the current data and the current plot. Each labeled circle represents one of the variables or dimensions in the current data. The variables with highlighted labels are part of the current scatter plot. This line inside the circle indicates the magnitude and direction of the coefficient of that variable. In the present plot, the variable labeled housing cost is plotted on the vertical axis. The variable labeled climate, representing climate mildness, is plotted on the horizontal axis. In this plot, each point represents the housing cost and climate mildness for a single U.S. metropolitan area. These data were collected and published by Rand McNally. The second function of the variable selection panel is that it allows a user to change one of the plotted variables with a single mouse click. Here's a second Xobi window containing a different view of this data on U.S. metropolitan areas. In this case, we're plotting the latitude against the longitude for each metropolitan area, and the plot suggests a map of the U.S. Suppose we would like to discover which parts of the U.S. have mild climates and low housing costs. This is a question involving four variables: climate, housing cost, latitude, and longitude. I will select brushing in this first plot, choose a color, and a plotting character, and proceed to use this rectangle as a paintbrush, painting each point touched by the brush. Since the other plot represents another view of the same data, the points on the map are brushed at the same time. We see a group of brushed points on the west coast. I'll scale the plot so that we can examine them more closely. I'd like to know what cities these are. So I'll select Identify in the main panel and now use the mouse cursor to find out the names of the points. Here's one of the brushed points that represents Bellingham, Washington. Here's another one, that's Richland. Olympia and Tacoma are brushed also. Just above those is Seattle, which didn't get brushed. So I'm going to select brushing in this plot, choose a different color and a different plotting character, and making a very tiny brush, I'll try to brush only Seattle. Returning to the first plot, we see that Seattle was indeed outside the scope of the paintbrush, and that the housing costs in Seattle are slightly higher than the costs in nearby Washington cities. For another use of scaling and identification, I'll turn to some data on telephone usage. This plot contains a time series representing the number of local telephone calls made during the course of 1 week. Each point represents the number of phone calls made in a single hour. There are 53 variables, one for the telephone usage during each week of a year and one for the hours in a week. At first glance, no pattern is apparent. I'll select the Scale button in the main panel and then use mouse motions to rescale the view of the data. Now the periodic shape of the data becomes apparent. I'll select Identify to see the day and hour labels. Each of these cycles represents the changing volume of telephone calls in a single day, with a low in the middle of the night and a high in the late afternoon to early evening. Now I'll turn to a different set of data to demonstrate xgobi's use of rotation and the grand tour. These are measurements taken on an experimental laser. There are 2 input currents, labeled I front and I back, and an output power and frequency. And if we cycle through the pairwise scatter plots of these 4 variables, we're not struck by any pattern in the data. If I select 3 of those variables and enter rotation, it's easier to see the 3-dimensional relationship among them. I'll remove the axes so that the rotating shape can be seen more clearly. Probably some features in the data are becoming clear to you now. We're looking at a 3-dimensional curved shape that resembles a cupped hand with parallel fingers. One of the fingers has a kink in it, however. I'll stop the rotation and brush the kink so that it stands out better. I also want to brush another unusual point that you may have spotted. The kink was discovered later to be an unstable operating region for this laser. The other point is a 3-dimensional outlier. We would investigate that further. Now I'll turn to a mode called the Grand Tour. Here we're watching a tour in 3 dimensions. The program selects a direction, and the rotation follows that direction for a few moments. Then the program chooses a new one. It is as if you were flying through the data in a helicopter on automatic pilot. With the Grand Tour, however, we aren't restricted to 3-dimensional space. I'll add the 4th variable. Now the helicopter's flying through 4-dimensional space. It takes time and practice to learn to interpret the Grand Tour, but sometimes it's the best way to find patterns and features in data with more than 3 variables. Multivariate data arise in very many fields and are quite challenging to analyze. xgobi, with its use of interactive dynamic graphical methods, can be a great help in this task. It helps users gain an intuitive understanding of their data and discover many relationships and features of a complex set of data. For more information about xgobi, send electronic mail to the address on the screen.